We've seen some application problems of what the derivative is telling us. Let's once again look at the derivative graphically. We've seen earlier that the tangent line at a point has slope which is equal to the derivative at that point. So the derivative of a function gives the slope of a tangent line. And that came from the fact that the slope of a tangent line is really the limit of slopes of secant lines. Let's go ahead and see how this actually pans out when we graph both the function itself and the derivative. Here is an example that we've done before. We've taken x squared plus 3x minus 2, and we've found that the derivative is 2x plus 3. We're going to look at the relationship between these two functions. So I have graphed both the function f of x and the derivative of the function f prime of x here. The f of x is in red and the f prime of x is in blue. So if you take a point on this graph and you start moving it around, what you're going to see is the slope of the tangent line should match up to the point on the blue line here. Let's go ahead and show you the tangent line. So I've taken a slider point and created the tangent line at that point on the graph. So I can click and drag on it. So as you can see, as you get to an x value of -2, the tangent line has negative slope and it's about a -1, right? It's going down at about a -1. And sure enough, the blue line has point -2, -1. As we move over to about -1.5, you can see the tangent line flattens out, which means that the slope of the tangent line is 0. And that's exactly where our blue line, our derivative, crosses the x-axis. As you move over more and more and more, notice the tangent line is getting steeper and steeper and steeper, and therefore the y value of this blue point, or this blue line, is getting steep, higher and higher and higher. Notice that before we were at -1.5, our tangent line had negative slope. So as we move on this line, our tangent line has negative slope. And that meant that the blue line was underneath the x-axis. It had negative value. So each time the point moves, the slope changes, and the changing of the slope is given to you by this blue line here. So that is a visual relationship between the function itself and the derivative of the function. I would like you to find the derivative for g of x equals 3x minus 7. And then I want you to graph the function and graph the derivative. And ask yourself, does it make sense that this is the derivative for this function? Utilize the definition of derivative in order to find the derivative of that g of x. So do this on your own, then graph it and ask yourself if it makes sense.